In this segment, we're going to be talking about how to use the thermodynamic tables, specifically the saturated water tables. So these tables are for water only. There are other tables for other substances, so just be aware of that. Make sure that you know what substance that you have. It's a really common mistake just to use the wrong tables for the wrong substance. And it's for saturated water specifically. So if you're in the two-phase region, if you're underneath the dome or you're on the dome, these are the tables that you're going to pull property data out of. And you have two sets of tables in your book. One set is organized by temperature, and you have tables in SI units, which is A2, and English units, which is A2E. And then you've got tables that are organized by pressure. These are the exact same, it's the exact same information. So one of those tables just might be more convenient for you to use. And you'll get an idea of what that means as we go through. So table A2 is organized by temperature. This is the SI unit one. So that first column, there's your temperature. So you've got temperature, pressure, got a couple of columns for specific volume, and then you've got some other property data, but we haven't really gotten to that yet. So I'm just going to zoom in on a certain part of that. All right, so here I am, I'm zoomed in. First column is temperature, second column is pressure. What's that pressure? Well, that pressure is my saturation pressure at whatever temperature that I'm talking about. So if you recall from one of the previous segments where we talked about TV diagrams, here I've got a TV diagram. Here's my liquid vapor dome. And say I'm at some temperature T1. If I draw a line of constant pressure through the line of constant pressure where the pressure in the two-phase region corresponds to that T1, that's my saturation pressure at T1, and that's the pressure that's tabulated in those saturated water tables. All right, now you've got a couple of columns for specific volumes. So why do you have a couple of columns? Well, it's because you have two phases present in that two-phase region. You've got you've got saturated liquid and you've got saturated vapor. So the V sub F is the specific volume associated with the saturated liquid. The V sub G is associated with the saturated vapor. And those subscripts, we carry those throughout the rest of the course. So any of the other property data, if you have property data that's got a subscript F or G, it just means it's associated with the saturated liquid and saturated vapor portion of a two-phase mixture, respectively. Let's put some numbers to it. So here we're looking at the line at 8 degrees Celsius. So let's go back to that TV diagram. So I'm going to draw a little line at 8 degrees Celsius. So anywhere along that line, my temperature is 8 degrees Celsius. I'm going to skip by the pressure right now, and I'm going to go straight to that V sub F. So the V sub F value is going to correspond to the location on that TV diagram where it runs into the 8 degrees temperature line and the saturated liquid line. So the V sub F, it's associated with the saturated liquid, so it's going to be right on that saturated liquid line. And the other thing to notice is that the V sub F value, because those are really, really small values, the numbers that are tabulated are multiplied, it's times 10 to the third. So the actual value, instead of being 1.0002, it's 0.0010002 meters cubed per kilogram. All right. And as you might expect, 120.917 meters cubed per kilogram, that's my V sub G. That's the specific volume associated with a saturated vapor. So right on that saturated vapor line at 8 degrees Celsius for water. All right. And then the last thing is the pressure. So the saturation pressure. If I draw a line of constant pressure, so anywhere along that purple dotted line, my pressure is 0.01072 bar or 1.072 kilopascals. That's my saturation pressure at 8 degrees Celsius for water. All right, and that's pretty much it. Now we do also have tables that are organized by pressure, so let's look at those as well. So first column is pressure. Once again, I'm only interested right now in pressure, temperature, and specific volume, so I'm going to zoom in on that. And let's look at a specific line. So, all right, I'm going to draw things on a PV diagram now. I could draw it on a TV diagram, but we'll do a PV diagram to mix it up. So I am at 0.1 bar. And my V sub F value is, well, it's also tabulated times 10 to the third. So the specific volume is 0.0010102 meters cubed per kilogram. So that would be corresponding right to that saturated liquid line. And then my saturated vapor, if I had a saturated vapor at 0.1 bar, then my specific volume would be 14.674 meters cubed per kilogram. All right, and then I could also draw myself a line of constant temperature, and that would be 45.81 degrees Celsius. So if I'm in that two-phase region and I'm at 0.1 bar, my water has to have a temperature of 45.81 degrees Celsius. If it's not at 45.81 degrees Celsius, then I'm not in the two-phase region. Maybe I'm compressed, maybe I'm superheated, and we'll look in one of the segments that are coming up on how to determine which one of those is the case. All right, thank you very much.